Look up on a clear night, far from the glow of the city, and you will find thousands of points of light scattered across the darkness. But there is one world you will almost certainly never see with your own eyes. It circles the sun at a distance so vast that its light takes more than 4 hours to reach us. That world is Neptune, the 8th and final planet of our solar system, and by far the least understood. Consider this: in the entire history of human exploration, only one spacecraft has ever traveled close enough to truly see it. In August of 1989, after a journey of 12 years and nearly 3 billion miles, Voyager 2 swept past Neptune. And then, in a matter of hours, it was gone, hurtling onward into the emptiness beyond. Everything we believe we know about this planet, nearly every photograph, every measurement, every scientific conclusion, rests almost entirely on that single, fleeting encounter. Think about what that really means. A world 17 times more massive than Earth, wrapped in storms and mystery, and humanity has studied it up close for only a handful of hours across all of recorded time. Voyager 2 captured its images while traveling at more than 60,000 kilometers per hour. It could not stop. It could not return. It simply looked, recorded, and moved on. There is a strange humility in that fact. We have mapped the ocean floor. We have split the atom. We have walked upon the moon. And yet, when it comes to Neptune, we are still standing at the very edge of knowledge, squinting into the dark, working from an album of photographs taken during one afternoon more than 3 decades ago. The distance is simply too great, and the visits too few. And so, nearly everything you're about to hear carries a quiet question mark behind it. The winds, the storms, the hidden heat, the impossible chemistry buried beneath its clouds. All of it was glimpsed, but almost none of it was fully explained. Neptune did not give up its secrets that day. It merely showed us enough to understand how much we still do not know. Because the very first thing Voyager 2 saw as it approached was something that should not have been possible, a storm that would soon vanish before our eyes. And that is where our journey truly begins. When the first clear images of Neptune arrived on the screens at the Jet Propulsion Laboratory, the scientists gathered there fell silent. There, in the planet's southern hemisphere, churned an enormous dark oval. A swirling tempest so vast that the entire Earth could have been dropped inside it and swallowed whole. They named it the Great Dark Spot. It resembled the famous Great Red Spot on Jupiter, and at first that seemed reassuring. Here was something familiar, a giant storm on a giant planet, the kind of feature that had raged on Jupiter for centuries. Surely, the researchers assumed this Neptunian storm had existed for a very long time and would continue for a very long time to come. It was a reasonable assumption. It was also completely wrong. Just 5 years later, in 1994, the Hubble Space Telescope turned its gaze toward Neptune to study the storm in greater detail. But when the images came back, the Great Dark Spot was simply not there. It had not moved. It had not shrunk. It had vanished entirely, as though it had never existed at all. In its place, the atmosphere had grown smooth and quiet, and a new dark spot had begun forming in the northern hemisphere instead. Try to grasp how unsettling that is for a scientist. A storm larger than our entire planet, powerful enough to reshape an atmosphere, had appeared and then disappeared within a handful of years. Nothing that immense should be so fleeting. On Earth, even our fiercest hurricanes are shaped by the friction of land and sea. But Neptune has no solid surface to slow a storm down, and yet its storms are somehow more temporary than our own, not less. To this day, no one can fully explain why the Great Dark Spot came into being, or why it dissolved so completely. We know it was real because we photographed it. We know it is gone because we looked again. Between those two truths lies a mystery that Voyager 2 was never able to solve, because by the time the storm faded, our one and only visitor had long since departed. But a vanishing storm was only the surface of the puzzle. Beneath those dark clouds, something was driving winds so violent that they defy the very laws we thought governed our solar system. Here is a question worth sitting with. What powers the wind? On Earth, the answer is the sun. Sunlight warms the air unevenly. Warm air rises, cool air rushes in to replace it, and the result is the breeze on your face and the gale that bends the trees. Wind, at its heart, is solar energy in motion. And that simple truth is exactly what makes Neptune so deeply confusing. Neptune orbits roughly 30 times farther from the Sun than we do. The sunlight that reaches it is nearly 1,000 times fainter than the light that falls on Earth. By every reasonable expectation, a planet receiving so little warmth should be sluggish, calm, and still, a frozen world where almost nothing moves. Instead, Neptune hosts the fastest, most violent winds ever recorded anywhere in the solar system. When Voyager 2 tracked the motion of Neptune's clouds, the numbers it returned seemed almost impossible. Winds were screaming across the planet at speeds approaching 2,000 kilometers per hour. Faster than the speed of sound here on Earth. Faster than any storm our world has ever produced. On a planet starved of sunlight, gusts were racing along at velocities that would tear apart anything we have ever built. This is the paradox that has puzzled physicists for decades. The energy budget makes no sense. A world receiving so little light from the sun should not be able to sustain such ferocious motion. It is as though a machine were running at full power with almost nothing feeding it fuel. Something else must be driving those winds. Some hidden source of energy that does not come from above, but from somewhere deep within. Some researchers suspect the answer lies in Neptune's strange internal structure, in heat that rises from within rather than warmth that arrives from without. Others wonder whether the very cold of the planet reduces friction, allowing winds to accelerate unchecked once they begin. The honest truth is that we do not fully know. We have measured the winds. We simply cannot yet fully explain them. And that hidden source of energy, the one that may be feeding those impossible winds, leads us to perhaps the strangest fact of all. Neptune, it turns out, is glowing with a heat that should not exist. Imagine holding a stone that has been left out overnight in the cold. By morning, it should feel as cold as the air around it. No colder, no warmer. That is simple physics. An object gives off only as much heat as it takes in. And by that same logic, a planet as distant as Neptune should radiate back into space only the meager warmth it receives from the faint and faraway sun. But Neptune does not obey that rule. When scientists carefully measured the energy the planet gives off compared to the energy it absorbs, they discovered something astonishing. Neptune radiates more than twice the heat it receives from the sun. In other words, more than half of the warmth pouring out of this planet is coming from somewhere else, from a source hidden deep inside the planet itself. This makes Neptune something of a furnace in the darkness. Deep beneath its clouds, some internal engine is generating heat, pumping energy outward through thousands of kilometers of atmosphere until it escapes into the frozen void. But what is that engine? What could possibly be burning, churning, or compressing down there to produce such steady warmth billions of miles from the nearest star? The leading ideas point to processes we can barely observe. Perhaps it is the slow gravitational settling of the planet's interior, heavier material sinking and releasing energy as it falls. Perhaps it is heat left over from Neptune's violent birth, still leaking out 4.5 billion years later. Perhaps it is chemistry we do not yet understand, unfolding under pressures we cannot recreate. Each explanation is plausible, none is proven. What makes this especially curious is the comparison with Uranus, Neptune's near twin in size and composition. Uranus, strangely, gives off almost no excess heat at all. Two planets born in the same neighborhood, built from similar ingredients. And yet one runs cold, while the other burns warm from within. That contrast alone tells us that something happened to Neptune, something we have not yet uncovered. To even begin searching for that inner furnace, we have to go back to the very beginning, to how Neptune was found. And that story is unlike the discovery of any other planet, because Neptune was not seen first. It was calculated. Every other planet visible to the naked eye was known to the ancients. Mercury, Venus, Mars, Jupiter, Saturn. Humanity has watched them wander the sky for thousands of years. Even Uranus, though faint, was eventually spotted through a telescope by an astronomer who happened to be looking in the right direction. But Neptune was different. Neptune was found not by looking, but by thinking. In the early 19th century, astronomers tracking Uranus noticed something troubling. The planet was not moving quite the way it should. According to Isaac Newton's law of universal gravitation, the same law that governs a falling apple and an orbiting moon, Uranus should follow a precise, predictable path. But it kept drifting slightly off course, as though some unseen hand were tugging at it from the darkness beyond. Two mathematicians working separately and unaware of each other's efforts, the Frenchman Urbain Le Verrier and the Englishman John Couch Adams, took up the puzzle. They reasoned that if Newton's law was correct, and it had never once failed, then the only explanation was another planet, farther out, whose gravity was disturbing Uranus. And so, using nothing but mathematics, they calculated exactly where that hidden planet must be. On the night of September 23, 1846, an astronomer in Berlin pointed his telescope to the precise spot Le Verrier's calculations had predicted. And there, almost exactly where the mathematics said it would be, sat a faint blue-green disk that had never been catalogued before: Neptune. A planet discovered first on paper by the pure force of reasoning, and only afterward confirmed by human eyes. Pause for a moment and consider the weight of that achievement. Human beings, standing on the surface of one world, use the invisible language of numbers to prove the existence of another world nearly 3 billion miles away, before anyone had ever laid eyes on it. It remains one of the most triumphant demonstrations in the history of science that the universe is written in a logic our minds can read. Yet the deeper we peer into that distant blue world, the stranger it becomes. For if the pressures inside Neptune are as extreme as we believe, then something extraordinary may be happening in its depths. It may be raining diamonds. It sounds like something invented for a story rather than something drawn from science. And yet, the idea that diamonds may rain down inside Neptune emerges directly from the known behavior of matter under extreme pressure. To understand how such a thing could be possible, we have to journey downward, from the cold blue clouds we can see, into a realm no probe has ever touched. Neptune is not a solid ball like Earth. It is what astronomers call an ice giant, a world made largely of water, ammonia, and methane, wrapped around a dense core. It is that methane, a simple molecule of carbon and hydrogen, that holds the key. As you descend through the planet, the weight of everything above presses down with ever-increasing force until the pressure grows millions of times greater than the atmosphere here at sea level. Under such crushing conditions, laboratory experiments have shown something remarkable. The methane molecules are torn apart, the hydrogen is stripped away, and the carbon atoms, squeezed together with unimaginable force, are compressed into crystalline structures. Carbon crystals, formed under immense pressure and heat, are precisely what we call diamonds. And so, deep within Neptune, diamonds may be forming continuously in the dark. What happens next is stranger still. These diamonds, being denser than the material around them, would begin to sink. Slowly, over vast stretches of time, they would drift downward through the surrounding fluid toward the planet's core. a silent, endless rain of precious stones falling through a world no eye will ever witness. Some scientists have even suggested the diamonds could grow large as they fall, accumulating into a glittering layer somewhere far below. This is not idle speculation. Researchers have recreated the crushing pressures of a planetary interior in the laboratory, using powerful lasers to compress plastic that mimics Neptune's chemistry. And they have watched tiny diamonds form in the flash of that impact. What theory predicted, experiment confirmed. The rain of diamonds may be one of the few Neptunian mysteries that we have actually managed to reproduce here on Earth. But Neptune's strangeness is not confined to the planet itself. Circling it is a moon that breaks one of the most basic rules of the solar system. A moon that moves entirely the wrong way. Almost everything in our solar system turns in the same direction. The planets orbit the sun in one great circular dance, all moving the same way. And nearly every major moon orbits its planet in that same direction too. This shared motion is a fingerprint of how the solar system formed, spinning out of a single rotating cloud of gas and dust. To move against that current is to defy the very story of our origins. And yet, that is exactly what Triton does. Triton is Neptune's largest moon, a frozen world roughly the size of our own moon. But unlike almost every other large moon in the solar system, Triton orbits Neptune backward, traveling in the opposite direction to the planet's own rotation. Astronomers call this a retrograde orbit, and it is a profound clue, because a moon born alongside its planet simply cannot form this way. Triton, in other words, was not born here. The most widely accepted explanation is that Triton did not begin its life as Neptune's moon at all. Instead, it was once an independent world, a wanderer from the distant Kuiper Belt, that vast ring of icy bodies at the outer edge of the solar system. Long ago, it strayed too close to Neptune, and the giant planet's gravity seized it, capturing it into orbit. Triton is not a native. It is a prisoner, taken from the darkness beyond. This captured past has left visible scars. Triton is one of the coldest known objects in the entire solar system, its surface plunging to nearly minus 235 degrees Celsius. And yet, astonishingly, Voyager 2 spotted geysers erupting from its frozen surface, blasting plumes of nitrogen high into the thin air. A world that cold should be dead and still, and yet it breathes. There is one final sobering detail to Triton's story. Because it orbits backward, the moon is locked in a slow gravitational struggle with Neptune, and that struggle is gradually pulling it closer. Over hundreds of millions of years, Triton is spiraling inward. Eventually, it will be torn apart by Neptune's gravity, and the debris may one day form a brilliant ring around the planet, the grave of a captured world. And speaking of rings, Neptune already wears a set of them today. But they are unlike any rings you have ever imagined, because parts of them should not be able to exist at all. When most people picture a ringed planet, they think of Saturn, wrapped in its magnificent luminous bands. Few people know that Neptune has rings of its own. They are faint, dark, and delicate, so difficult to see that for years, astronomers were not even certain they existed. Some observations seemed to show rings, others showed nothing at all. The rings appeared to come and go, and no one could say why. The mystery deepened when observers realized the rings did not seem to form complete circles. Instead of continuous bands encircling the planet, they appeared to detect only broken arcs, short curved segments of material hanging in space, with vast empty gaps between them. This was deeply puzzling, because the laws of orbital motion should smear such material out evenly into a full ring over time. Clumps should not survive. And yet they did. It was Voyager 2, once again, that finally settled part of the question. As it passed through the Neptunian system, it confirmed that the rings were indeed real, complete circles after all. but that within them lay these strange, dense clumps of material, arcs where the ring particles gathered together instead of spreading apart. The brightest of these arcs were given names, drawn from the ideals of the French Revolution: liberté, égalité, fraternité. So what holds these impossible clumps together? For decades, the leading theory suggested that a small nearby moon acted like a shepherd, its gravity gently corralling the ring particles and keeping them bunched into arcs. It was an elegant idea, but there was a problem. When astronomers looked, the arcs did not stay put. Over the years, some of them appeared to be fading and decaying, shifting in ways the shepherd theory struggled to explain. Here again, we meet the recurring theme of Neptune. We can see the rings. We can name the arcs. But the fundamental forces holding them in their strange, clumped shapes remain only partly understood. And some of those arcs may be crumbling even as we watch. The rings, like so much of this planet, exist in a state that our best physics can describe, but not yet completely justify. If the surface and the rings are this bewildering, imagine what lies beneath. Because somewhere below Neptune's clouds, scientists believe there may be an ocean, but an ocean unlike anything that has ever existed on Earth. We tend to think of an ocean as something familiar: cool water, a shoreline, a surface you can float upon, a floor somewhere far below. But the ocean that scientists believe hides within Neptune obeys none of those comforting rules. It has no shore, it has no clear surface, and it may have no bottom at all, at least not one we would recognize. As you descend into Neptune, there is no sudden line where atmosphere ends and ocean begins. The gases simply grow thicker and hotter and denser, pressed together by the crushing weight above, until gradually and without any clear boundary, they blend into a hot, dense fluid. It is a slow transformation from sky to sea, with no coastline to mark the change, a seamless plunge from cloud into liquid. And this is no ordinary water. Under the staggering temperatures and pressures within Neptune, water is forced into bizarre states that do not exist naturally anywhere on our planet. Scientists speak of a strange substance called supersonic water, a form of water that is simultaneously solid and liquid at once, in which the oxygen atoms lock into a rigid crystal, while the hydrogen flows through them freely, like a current running through a frozen lattice. Picture that for a moment. A material that is frozen and flowing at the same time, black and hot rather than cold and clear, conducting electricity through its very structure. This is not the ocean of any earthly imagination. It may in fact be the source of some of Neptune's deepest mysteries, including the electrical currents that generate the planet's tangled magnetic field. The ocean and the magnetism may be one and the same phenomenon. We have never sampled this ocean. We have never sent a probe into those depths, and with today's technology, we simply cannot. Everything we believe about it comes from calculations, from laboratory experiments squeezing water to planetary pressures, and from the faint clues Voyager 2 gathered as it flew by. The ocean of Neptune remains, in the truest sense, an ocean of theory, vast, dark, and almost entirely unexplored. And that tangled magnetic field, born perhaps from this impossible ocean, holds one of the most chaotic secrets of all. Because on Neptune, even the magnetism is lopsided, tilted, and wildly out of place. Here on Earth, we are protected by an invisible shield. Deep within our planet, molten iron churns and generates a magnetic field, and that field wraps neatly around us, streaming out from near the North Pole and curving back toward the south. It is orderly and centered, roughly aligned with the axis on which our world spins. It is, in a sense, tidy. Neptune's magnetic field is anything but. When Voyager 2 measured Neptune's magnetism, it found something deeply strange. The magnetic field is not aligned with the planet's spin at all. Instead, it is tilted by an enormous angle, nearly 47 degrees away from the axis of rotation. Imagine a bar magnet shoved into a spinning ball at a wild, crooked angle, and you begin to picture just how disordered Neptune's field truly is. Stranger still, the field is not even centered within the planet. On Earth, our magnetic field arises from near the core, close to the center of the world. But Neptune's appears to originate from somewhere offset, away from the middle, as though the source of the magnetism were shoved off to one side. The result is a magnetic field that is lopsided, tilted, and chaotic, one of the most disordered planetary fields ever discovered. This chaos is a powerful clue about the interior. A neat, centered field, like Earth's, suggests a neat, centered engine deep in the core, but a tilted, off-center field, like Neptune's, suggests the opposite, that its magnetism is generated not deep in the core, but higher up, within that strange superionic ocean, churning in the outer layers. The very disorder of the field points back toward the exotic sea we spoke of before. And so each mystery on Neptune ties itself to the next. The impossible ocean may drive the chaotic magnetism. The internal heat may drive the impossible winds. The vanished storms, the fleeting arcs, the backward moon, none of them stand alone. They are threads in a single tangled knot, and pulling on any one of them tightens all the others. Neptune is not a collection of separate puzzles. It is one great puzzle wearing many faces. There is one more strange truth about this distant world, and it is a matter not of space, but of time. Because on Neptune, a single year lasts almost longer than we can comprehend. We measure our lives in years without ever really thinking about what a year is. It is simply the time our planet takes to travel once around the sun. A single loop, 365 days. One full circle. But a year is not the same everywhere. The farther a planet lies from the sun, the longer its journey and the longer its year. And Neptune lies farther out than almost anything we know. So vast is Neptune's orbit that a single trip around the sun takes 165 Earth years. Let that number settle. 1 year on Neptune is longer than the lifespan of any human being who has ever lived. A person could be born, grow old, and pass away, and their children and grandchildren after them, and still Neptune would not have completed a single circuit of its long, lonely path. This leads to a fact that is quietly astonishing. Neptune was discovered in the year 1846, and because its year lasts 165 of ours, the planet completed its very first full orbit since its discovery only recently in the year 2011. For the entire history of Neptune as a known world, from its first sighting through 2 world wars, the rise of flight, the splitting of the atom, and the landing on the moon, the planet had circled the sun only once. There is something humbling in that thought. All of modern human history, every invention, every generation, every great change in the world since 1846 has unfolded in the span of just one Neptunian year. To that distant blue giant, drifting silently at the edge of the sun's domain, the whole story of the modern age is barely the passing of a single season. Our lifetimes are moments to a world that measures time so differently. And out there it still turns, patient and unhurried, in the deep cold and the dark. It does not know we exist. It does not know it was found, or named, or photographed for a few brief hours by a single passing machine. It simply continues, as it has for 4.5 billion years, tracing its enormous silent circle around a sun that from its distance looks like little more than a bright and lonely star. Which leaves us with the most important question of all. Not what Neptune is, but what we might finally learn. Because everything you have heard today could soon be transformed by what comes next. We have traveled together across 3 billion miles of darkness and 30 years of unanswered questions. We have seen a storm that vanished, winds that should not blow, heat with no clear source, an ocean unlike any on Earth. a moon moving backward, and a year that outlasts a human life. And through it all, one truth has echoed again and again. Almost everything we know about Neptune rests on a single afternoon in 1989. We have been reading one page of a very long book, but that may not be true for much longer. For years, scientists around the world have been calling for a return to Neptune, a dedicated mission that would not simply fly past in a matter of hours, but arrive, slow down, and settle into orbit. Such a spacecraft could watch the planet's storms form and fade across years rather than moments. It could probe the strange chemistry of that hidden ocean. It could measure the tilted magnetic field from every angle and search, at last, for the source of that impossible inner heat. A mission like this would do more than answer questions about one distant planet. Ice giants like Neptune, we now believe, may be among the most common types of worlds in the entire galaxy. When astronomers peer at distant stars and find planets circling them, many of those worlds appear to be Neptune-sized. To truly understand Neptune, then, is to hold a key that could help us understand countless other worlds far beyond our own solar system. And so, the mysteries we have explored today are not endings, they are invitations. Every unanswered question, the vanished storm, the diamond rain, the backward moon, the ocean with no bottom, is a door still waiting to be opened. The story of Neptune is not finished. In many ways, with the right mission and the patience to reach that far, it may only just be beginning. What we learn there could quietly rewrite our understanding of how planets are born. If you have journeyed with me all the way to the edge of the solar system, then this final part is for you. If this exploration of Neptune stirred your curiosity and made that distant world feel a little closer, take a moment to subscribe to the channel so you will be here when we venture out to the next great mystery of the cosmos. Leave a like on this video to help others discover it as well. And I would truly like to hear from you. In the comments below, tell me this. Of all the mysteries we uncovered today, which one do you find the most extraordinary, and what corner of the universe would you like us to explore next? I will be reading your answers, and your voice will help shape the journeys still to come. Until then, look up on a clear night. Somewhere out there, far beyond the reach of your eyes, a silent blue world is still turning, and it is still keeping most of its secrets.